Alrighty, so first of all, when we have a dy dx, we're going to be replacing that with r dr d theta. Every time dy dx becomes r dr d theta. Great, and we didn't have anything here, so that's understood to be a 1. Sometimes you might have something there. In our next example, we will. So this would just be a 1 represented here. So we would just have a 1 there. Now, our interior part right here says that y goes between the square root of 25 minus x squared and 0, which is important that y is greater than or equal to 0. That's going to come into play. But let's look at our upper boundary. So let's say that y equals this upper boundary. If I square the y, square both sides, this is what it looks like. And I move the x squared over, so x squared plus y squared would equal 25. Well, what's special about that is x squared plus y squared is r squared in the Cartesian system. So r squared is 25. So r is going to equal 5. Now, you'll say, why didn't you use the square root property? Well, r is a distance. It's the radius, right? So radius can't be negative. So since r is a distance, it's going to go from 0 to 5. So r is my interior function here, so it's going to go from 0 to 5. Now, let's look at the other part. The other part says that x lies between -5 and 5. Okay, so here's where x would lie. And I know this is a circle because x squared plus y squared equals 25 is a circle. So here's what the circle would look like. Not a very good circle, but that's a circle. But remember earlier I told you that y had to be positive? So y can't be down here, right? So y has to be from here to here, and this would be the area because it tells me y has to be from here to here. Now let's talk about theta for a second. Here's 0, and then the graph is going to stop right here because it can't go below the value, right? So theta is going to go from 0 to pi because it told me that y was positive, so y is not going to be down there. Okay, so that's how I set it up, and that's the hardest part. I'm going to integrate with respect to r, so I'm going to get r squared over 2. And I'm going to be evaluating that from r equals 0 to r equals 5, which would just give me 25 over 2. So then I'm going to be evaluating that with integrating that with regards to theta. So this is going to be a 25 over 2 theta, and theta goes from 0 to pi. So this would be 25 pi over 2 minus 0, which would just be 25 pi over 2. And that's how it would look. Okay, so here's your second one. Okay, again, we're going to look for y, because y is here. Y is going to be more than 0, so that's going to be a familiar stretch there. And it's going to be between these values. Okay, so if I set it equal to the upper bound, square both sides, move the x squared over, I'm going to get that r squared is 64. So r is going to be 8. So this interior part right here is going to go from 0 to 8. And remember, dy dx is r dr d theta. Okay. Now here, I have x squared plus y squared. So I know that x squared plus y squared is r squared. So that is how the x squared plus y squared is going to play out. It's just going to be r squared. All right, so let's graph it. I know that this is going to be a circle with radius 8. So it's going to go 8 this direction all the way around. Something like that. All right, so x goes from here to here. So I know I'm going to go there. And it tells me that y, again, is greater than 0. So it wouldn't be down here, it'd be here. So again, if this one goes from here to here, that's going to be 0 to pi. Now let's just talk about it for just a quick second. What if it had said that x went from 0 to 8? So if x went from 0 to 8, that would be from here to here. And if y was positive, that would be from here to here. So you would only be looking at this quarter circle here. So remember that in both of these, I said that x went from negative to positive, right? But if x was only in this piece right here, you would just take it from 0 to pi over 2. You've got a problem in the somewhere like that, so I just want you to be familiar. All right, so let's get back to the problem at hand. Here's how it looks. So when I put these together, I'm going to get 0 to pi of 0 to 8 of r cubed dr d theta, which would give me r to the 4th over 4. I'm going to be evaluating that from 0 to 8. Whew. So I'm going to get 8 to the 4th over 4 d theta. Okay, I don't know what 8 to the 4th is. Let's see. $4,096. Let's see. Sorry, I don't have a calculator today. You would think I would. So let's divide that by 4. I get 1024. Okay, so this is going to be 1024 d theta, which is going to be 1024 theta, evaluated from 0 to pi, which would be 1024 pi as my answer.